Hello guys, welcome to all of you. Let us see a question which is asked in GATE 2018. In the circuit shown below, the W by L value of M2 is twice that for M1. W by L value of M2 transistor is equal to 2 times W by L of M1 transistor. The two NMOS transistors are otherwise identical. The threshold voltage VT for both transistors is 1 volt. So VT for both transistors is given at 1 volt, and it is given that VGS for M2 must be greater than 1 volt. So this is the circuit given, and these are the drain current equation given for a transistor working in linear region and working in saturation region. The voltage Vx value has been asked accurately up to 2 decimal. Let us see how can we solve this question. As given in the question that W by L value of transistor 2 is equal to 2 times W by L value of transistor 1. VT of both transistors is given 1 volt. Here we can see for transistor M2, VGS2 is greater than 1, which is given in the question. So VGS2 can be written as VG2 minus VS2, and here in the question VG2 is given as 2 volt. So here in the circuit we can see that this VG2 voltage is given as 2 volt. So we have put VG2 is equal to 2 volt, and we calculate VS2, then that will be less than equal to 1 volt. In the circuit if we see, then this VS2 is Vx volt. Here in the circuit this VS2 source voltage of transistor 2 is Vx volt. So we put it here, then we can find out Vx is less than 1 volt. Now we will apply method 1 to find out the region of operation of both the transistors. Here, if we calculate overdrive voltage of transistor M1, then it will be VGS1 minus VT. VGS1 voltage will be equal to 2 volt, since this is the 2 volt and this is 0 volt. 2 minus 0 is equal to 2 volt, and VT is given 1 volt, so it will be 1. And if we calculate overdrive voltage of transistor M2, then it will be VGS2 minus VT. So VGS2 of this transistor M2 can be written as 2 minus Vx, and minus VT is equal to 1 volt. So it will be 1 minus Vx. We have calculated that Vx is less than 1 volt. So VGS2 minus VT should also be less than 1 volt. Here we can see that the overdrive voltage of transistor 1 M1 is greater than the overdrive voltage of transistor 2. So the transistor which have higher value of overdrive voltage will be in linear region, and the transistor which have lower value of overdrive voltage will be in saturation region. So from this interpretation we can find out that M1 is in linear region and M2 is in saturation region. We can use second method to find out the operation of region of these two transistors. Here we can calculate overdrive voltage of transistor M1, then this is VGS1 minus VT, this 2 minus 1 is equal to 1 volt. If we calculate VDS1 voltage, then it will be equal to Vx volt. Here VDS1 voltage is Vx. Here we have calculated that Vx is less than 1, so this VDS1 which is less than 1 volt, but this overdrive voltage is 1 volt, so this value will be less than this overdrive voltage. So VDS1 is less than VGS1 minus VT, that is the overdrive voltage. So we can say that M1 is in linear region. As we know that if VDS voltage is greater than equal to VGS minus VT, then transistor will work in saturation region, otherwise it will work in linear region if VGS is greater than VTS. For transistor 2, if we calculate overdrive voltage VGS2 minus V2, then VGS2 will be equal to 2 minus Vx, and VT minus 1, it will be 1 minus Vx. And VDS2 can be calculated from VD minus Vs, this is 3.3 minus Vx. So we can see here that this VDS2 voltage is greater than this overdrive voltage. So we can say that M2 will be in saturation region. I have calculated that M1 is in linear region and M2 is in saturation region, but we can see that the ID current flowing from M2 will also be equal to flowing from M1. ID1 current will be equal to ID2, but M1 is in linear region, so we will apply formula of linear region, and since M2 is in saturation region, so we will apply formula used in the saturation region for transistor. This is the formula for the drain current of MOSFET when it is operating in linear region, and this is the formula for drain current of MOSFET when it is operating in saturation region. This is also given in question. For this question we don't need to remember this formula as it was given in the question. So if we see, then VGS1 minus VT will be equal to 1 volt, VGS1 minus VT is equal to 1 volt, and VDS1 is equal to Vx, so we put these values here. Here we can see VGS2 minus VT, VGS2 minus VT is 1 minus Vx, so we put it here, and we also apply the information given in the question that W by L2 is equal to 2 times of W by L1. So we put these values here, then we will get a quadratic equation in Vx, and we will find two values of Vx here, that is 1.577 and 0.4226. If we choose Vx is equal to 1.577, then we can find out that overdrive voltage of transistor 2 is less than 0. That indicates that this M2 should be in cutoff region. But we have seen that our M2 transistor is in saturation region. So this value of Vx, that is 1.577 volt, will not be applicable here. If we take Vx is equal to 0.4226, then VGS2 minus V voltage is 1 minus Vx, then it is 0.5774, and VDS2 will be 3.3 minus Vx, that is 2.8774. So VDS2 voltage, that is the drain to source voltage, is greater than overdrive voltage. So we can say that M2 is saturation region. For M1 transistor, overdrive voltage is 1 volt and the drain to source voltage is 0.4226. So we can see that this drain to source voltage is less than overdrive voltage, so M1 will be in linear region. So this is also matches with our initial conditions. So we can say that for the value of Vx is equal to 0.226, our M1 will be in linear region and our M2 will be in saturation region. So Vx value will be equal to 0.4226, and this value is also less than 1, which also satisfy our condition that was given in the question, that VGS2 is greater than 1 volt. So this is our answer.